Okay guys, hello and welcome to your second tutorial in game development. So, last tutorial we set up the screen, and this tutorial we are going to focus on putting some pixels to the screen. So I'm going to make a new folder, I'm going to call it GFX, call it graphics or anything, doesn't matter. And we're going to create a new class called bitmap. So, let's set this up. Public class bitmap. So the bitmap, basically what it's going to do is going to store just basically a load of pixels, really, is the simplest way of putting it. So we need to store three main variables for this: the width and the height of the bitmap, and of course the actual array of pixels for this bitmap. And we'll talk about more how we actually represent color in integers later. So we're going to create a couple of different constructors here. We're going to create our main constructor, which will be int width, int height. This dot width w is equal to width. This dot h is equal to height. This dot pixels is equal to new integer array width times height. Okay, there we go. So we've actually now got the setup, so it will correctly create the new bitmap when we enter that in. The next constructor we're going to make is a little bit more complicated. So this one is going to take what we call in Java a buffered image. A buffered image is basically just a default variable in Java that will store an image, really. So we're going to do this dot width is equal to image dot get width, not height. These bits are simple. Image dot get height. This bit's the more complicated bit, getting the pixels. So I'm going to do this, and then I'm going to talk you through it. So the data buffer int cast of image dot get raster dot get data buffer dot get data. Control Shift O. There we go. Right. So basically, what this does is it's going to take all the pixel data from this image, and it's not only going to put it in pixels, but it's also going to make it act as a reference to pixels. So what this actually means, what is going on with my highlights here? They're all over the place. Good job, Eclipse. It's going to act as a reference to these pixels. So basically what it's saying here, anything we put in this array of pixels, what the hell is going on with these? Anything we put in this pixel array here will get dumped into this buffered image. Okay? That's the easiest way I can think of explaining it. So when we change these pixels, it's going to change the image here. So what we now need to do is we need to actually make one of these. So let's go back into our main method, and we're going to go make a public buffered image called screen image. Excuse me. We're going to create a public bitmap called screen. Okay, so now we need to initialize these in our constructor. So the screen image is going to be equal to a new buffered image width, height, and buffered image dot type underscore int RGB. And what it's basically is telling it we want to create a buffered image with the width and height we defined up here. We're not timesing it by scale because we want to give it the pixely effect. We only times the window size by scale. And buffered image.type int RGB tells the program that the pixel data in there will represent the RGB or red, green, and blue values for each pixel. We're then going to set the screen equal to new bitmap, and we're going to pass screen image as the parameter. So basically we've now got all of this set up. We've got this thing feeding in, but we now need to actually draw these pixels to our screen. So we're going to go into our render method here. We're going to make a buffer strategy. PS is going to be equal to this dot get buffer strategy. And we're going to say if BS is equal to null, this dot create buffer strategy 3 and return. So basically we're going to try and I won't go into explaining what a buffer strategy is because I don't know what it is. I don't think it's necessary really. We're basically going to get the buffer strategy of this canvas that we're running on. If we don't get it, we want to create a buffer strategy and leave the method so that we come round to it next and we'll have a buffer strategy. So we're going to do screen dot. Okay, right. We need to do some things here. Graphics G is going to be equal to no BS dot get draw graphics. So we're going to get the graphics from this strategy that have been taken from the canvas, apparently. And then this is the big method. We don't need to do all of this, but we're going to do this dot screen image 0, 0 width height and null for the image observer, which is something we don't want at the moment. Okay, so we're basically going to draw this screen image we have, and we're going to draw it onto the screen. We're then going to do g.dispose, so we get rid of the graphics, bs.show, so that we actually put it on the screen. And we're going to get this, which is an incredibly annoying effect, and it's because I've forgotten in here to put times scale. Because these are dimensions on the window we're drawing the image, so these ones do need to be multiplied by the scale. So we run this now, we're going to get completely black screen because there is no pixels here. So what I'm going to do here, just to check that we actually have got this all set up correctly, we're going to create a bitmap, just a temporary method that we probably won't keep, called randomize. So we create a random seed up here, or random object, not seed, sorry. Random. So for int I equals to 0, while I is less than pixels dot length. So we're iterating through every pixel on our screen. Pixels at I is going to be equal to r dot next int not x ff. Don't worry about that number in there. We'll talk about that later when we go into color representation in hexadecimal. If you followed my LWJGL tutorials on texture loading, you should know about that already. Okay, yeah, we do actually need to call it screen.randomize. Save, and there we go. So we've got just completely random pixels generating each time. So that's good. We have all of these methods set up. So yeah, that's really cool. I'm glad that's worked first time. Is there anything else that I need to go through here? So basically this just acts as a reference. I know this bit looks quite complicated. You don't need to worry about this get raster, get data buffer, get data. You're basically just getting the data from the image, and you're saying we want the pixels to reference it. So anything we put in this array of pixels will get dumped into the image. So anything we put in this array of pixels will get dumped into this image, which gets drawn to the screen because we've initialized this bitmap with the screen image here, and then we draw it to the screen at the coordinates 0, 0, max, and then we give it the width and height, width times scale and height times scale. We don't give it an image observer, and we just get rid of it and do it again. So yeah, that's been basic getting pixels on the screen. I hope you've enjoyed this tutorial, and I will see you next time where we'll go over actually making sense of this weird number I typed in here. Okay, thanks for watching. See you next time.